Okay, so for you 40S students, I'm now recording today's class as I had recorded yesterday's class and have been recording. So yesterday we continued our look at interfaces and I recorded that class. In a sense, we completed our look at interfaces, although I know I went a little long and you might have had to go back and kind of update your example. My apologies for that. So the video is online. I realize it was a bit long. It was a 37-minute video, okay? And by the very end of that video, I kind of rushed a little bit to get that code in there. But you can always go in and pause the video and get that code, okay? You also obviously have the option of going onto GitHub, and the GitHub code is there, and it's up to date, and you can copy and paste. Just, as always, be a little leery about copying and pasting too much code off of GitHub, because if you copy and paste too much off of GitHub and don't actually key it in and don't actually follow along, you're not really going to learn it. You're just not, okay? You're not going to learn this code. And so remember, what I would probably expect you guys to do is to copy and paste things like this, long comments that I put in there, so that it kind of explains the concept. But as far as actual lines of code go, those I think to activate your kinesthetic memory would be good for you to actually key in to help learn them. Okay, same thing. Any questions for you guys before we get going today? If you have questions, put them in the chat window or turn on your mic. I do that weird speaker check because sometimes my speaker goes to sleep and it just essentially turns off and I don't hear the questions. All right, so let's pick up where we left off yesterday. So yesterday, we were dealing with these ideas of interfaces, okay? Having worked on abstract classes. So actually, let me start today with this, just a little review of kind of where we're at. We started this advanced classes unit by first learning, or if you learned it last year, reviewing the concept of classes itself. If during the pandemic you didn't get a full lesson on classes at all, then maybe this was learning it for the first time. So what is a class? What are properties? What are methods? What's an object? What's inheritance? What's encapsulation? What's association? And all the kind of vocabulary that went with that, like super and this and override and private and public and has-a and is-a. All of that terminology got applied to the learning of classes. And then in the 40S content, we continued that into a more advanced level. So one of the things to help explain these concepts of classes to you guys is I showed you that there's this thing called UML diagrams. Yes, they can get more complicated, right? They can include information about the properties and methods, and they have a certain style to them. But we went with a simpler sort of guiding format here that when one class inherits from another class, we'd use a certain style of arrow. When another class just uses another class or is associated or is composed of another class, we would use a different style of arrow. So for example, our first three classes, we made a person class, we made a student class, which is a person, and we made a book class, which is used by the student class. So a student has a book and a student is a person, and all the terminology and the guidance that kind of went with that. So the diagram helps me to try and say a little bit less and try to visualize what's going on here. So then we added a teacher class, and all of this was being done inside of our testing class, the advanced classes test class. So the testing class was using the person class, using the student class, and eventually using the teacher class. The teacher is a person, the teacher has a student, and all of the diagram starts to maybe come together a little bit. You will notice something on the diagram here I drew. This is sort of this curved here implies that the line is jumping over the other line. Whereas in other places I put a solid dot indicating that the line is joining the other line. So think of it again like flowing. But from any one class, like this class student right here, you can see the classes that are using student. So these two classes are using student. You can see that student is using another class and that student is inheriting from another class. So this shows what's called dependency, that the student class is dependent on the book class and it's dependent on the person class. for example. Whereas two other classes are dependent on the student class. The testing class and the teacher class are dependent on the student class. Okay, moving forward. We then learned about this fancy class called the object class, which every class inherits from. So now putting together all the other classes that we did in our previous unit called recursion, and even classes we didn't write, like J-option pane and system, we saw that everything inherits from the object class. We then expanded out and added more classes, like the doctor class, the baker class, the high school, the husky, the piper, and the Mr. Walks class, and how all of those were interconnected to our other classes. Some were interconnected through inheritance, some were interconnected through usage. That can get complicated when I say those fancy words. So maybe just simple words like Mr. Walks is a teacher, and a teacher is a person. The advanced classes test has a Mr. Walks in it. It has a husky, which is a high school, which is a student, which is a person. Okay. Then we also made a class called meeting, and the meeting class incorporated the person class. And because the person class is the parent of so many other classes, it was a good opportunity to discuss things like polymorphism, and use something fancy like the enhanced for loop and the instance of code. So I was able to bring a little bit of extra code in there as part of our discussion on advanced classes. So here was kind of the big diagram of all these classes starting to connect together, okay? Then, now looking at the list, now we can check off things like what an accessor, what a mutator, a setter, and a getter. With the object class, including toString, clone, and equals. We took time to modify our templates so that we made the coding a little bit easier. We looked at this thing called protected, which is a kind of fancy property modifier word. We had the enhanced for loop, the static modifier, instance of. And then we started looking at the idea of abstraction. And specifically, we started with the abstract class, which cannot be instantiated, but are used to stand as a parent class for other classes. If we incorporate it into the UML diagram, which we did, we made the high school class abstract, but then we also made an abstract class called food, and then we made children of the food class apple and steak, okay? And then expanding that out to the diagram, okay, we used those classes with other classes and wrote a little method that could deal with that, a method called consume, so that our person can consume food, and that uses polymorphism and abstract classes and abstract ideas. And then we moved yesterday towards the idea of an interface, which is an even more abstract concept. You should think of an interface like a set of rules to follow, okay? So now we're adding a different style of arrow. I kind of made a mistake yesterday. I drew the wrong style. So a different style of arrow, which means it implements an interface or it follows the rules. So we created a series of interfaces, sports, hockey, football, and permission form. And they were all used by the athlete class, which was an extension, okay, or inherited from the husky class. So here is that diagram, or I think I have it here, yeah, without, or actually let me back up a bit. So there it is, there's our diagram as of yesterday's class, with all of our classes other than these three. These three we didn't write. Those are built into Java, same with object. But other than that, we've created all of these classes in this example since the start of February. It's been a lot of concepts in this unit, a lot of concepts all based around the idea of classes. So that's why the unit's called advanced classes. The final thing we're going to check off now, the final piece of this is the idea of generics, okay? It's the final piece of vocabulary, and it's the final concept check off. Now I'll give you a preview of what we're going to be building. We're only going to be building 2 more classes. There they are right there in yellow. So there's only going to be 2 more classes added to the big set of classes that we've already been making. So if we look at our example, come on, there it is. All of these classes stored inside the package and the testing class. Okay? All of these classes have been part of this example, okay? Since the start. We're going to put 2 more in there before the end of the period tomorrow. And then this example will be done. There isn't a lot of code for either of these, a little more than we've been doing with the interfaces recently, but it's how this code all comes together. So there's going to be some comments that are going to go in there as well. Okay, so let's start at our testing class. Do a speaker check. So I wanted that little review just moving forward before we start the idea of generics today. Okay, is there any questions now moving forward about where we've gotten here? It's a lot. I know I don't mean any, like it's a lot of stuff that you guys have hit here in this unit. Especially if you hadn't learned classes from last year because of the pandemic. It's a lot hitting you at once here. All right. So what are generics? So the word generic, just that word outside of computer science, essentially just means a characteristic relating to something not specific. Something that's generic means it's not a specific thing. In Java, we can create generic classes and generic methods. Okay, so we're going to start with a generic method. All right. So going in our testing class, we're now going to add some code after the stuff we did. And I'm going to just pause here for a second. First on this comment, right? So this comment about interfaces. So if you don't have that comment in your example, you should get it off GitHub. And then this code right here. This was the code I rushed to do yesterday. And so I'm putting this in here in the video, so you could also pause the video right now and just double check to make sure you have the code here moving forward, right? Play this based on the code we finished with yesterday. It would show 4 rounds of this sporting event. Round 0, Wayne gets his permission form signed. Round 1, he scores a goal. The Piper scored a point. Then it tells you what the score is at the end of the period and the end of the quarter. Then the same with round 2 and then round 3. And then Wayne would win and he would have a steak by grilling it on the barbecue. Okay? Because of this last piece right here. So today, what we're going to do is we're going to create and use generics. I'm adding this comment in here right now. Generic is defined as a characteristic of or relating to a class or group of things that's not specific. In Java, we can use generic methods and generic classes. But before we do that, let's make some very simple variables. Something that you would have started the grade 11 course with. These are very basic, like Boolean variable is probably the simplest variable type there is. This is called Boolean B for Boolean, equals true. The Boolean is the simplest type of variable. So these data types are often called primitive data types. That's why the word Boolean starts in a lowercase b and it's a keyword. The next simplest data type would be probably integer. Integer is also a very simple data type. Just a number. It doesn't worry about decimals, it's just a number. The next one would be double. And let's use a traditional double. That's a double data type. And then let's also make a character data type. And we'll make that the letter A. Okay. These are primitive data types. They're the simplest data types there is. Okay. Couldn't be simpler. Okay. Could not be simpler. Now, the next thing we're going to do is something that you may have kind of seen before, but we're going to use the primitives, the data types we just made, and make more complex data types. These are class types. So instead of Boolean with a lowercase b, we're going to make Boolean with a capital B. This is a class, and it's technically what's called a wrapper class. Okay, so let's call it bool equals. And since it's a class, we can use a constructor for it. A new Boolean. I'm going to pass it because, believe it or not, the Boolean data type actually has constructors. Two of them, actually. One, it can construct a Boolean from a Boolean, and notice that Boolean uses the lowercase, so that's the primitive data type. And it can also create a Boolean from a string. So if I was to give it this, it could make a Boolean. But instead, I'm going to give it just B. Now, here's something weird that Java's going to do. Not Java, but NetBeans. It's going to put a line through the word Boolean. And that's because this is what's called a depreciated constructor. And it's saying here, this is unnecessary to do this. So the suggested code it would do would be to just do that, which is simpler, okay? Which is fine, there's nothing wrong with that, but I wanted this in here just as a reminder that you can do this. All right, now we're gonna do an integer. And we'll call it integer. And I'm going to give it I as my integer. Okay, so it's a very simple data type. And then I'm going to make a double. I can't say double here because then it matches up with what's up here. I'm just going to take the letters off. Double dub equals new double. And I'm going to pass it D. And then character equals a new character. And I'm going to pass it C. So I am building complex data types from the simple data types. There's a reason for this. But we started off with primitive. This is what you would have learned in the grade 11 course, right? Just simple primitive data types. These are essentially the same thing, but now they're using classes. So it kind of touches on what we've been dealing with in this unit, constructor methods and classes. So theoretically, I could go into the class, the object of that class, and use the built-in methods that are a part of it, which includes toString, equals, clone, etc., like that. Okay, but I'm not going to do that. Okay, and we also can't forget about string. String was already a complex data type. Okay, you actually learned that back in the grade 11 course. String equals new string. Okay, and the string actually has multiple constructors. But I'm just going to build it up from a word, and that word would be just text. Okay, so that's me building a string object called string by creating a string which was always a complex data type. That's why it had the capital S. Okay. So I'm going to use these 1, 2, 3, 4, 5 data types in a complex way. But I'm going to call a generic method to do this. So I'm going to create a generic method that can do this thing. The generic method is just going to be called output. So I'm going to output the bool. I'm going to output a bunch of other stuff. An integer, a double, a character, and then even something that isn't one of these data types that are built into Java. Like all these are built into Java. I'm going to use my jock, output my jock. Jock is the data type athlete. So it's a data type I made. I created that data type. So we created primitive data types, turned them into complex data types, including string. So we started off with primitives. Then we turned those into complex data types. And now what are we going to do here? We're going to call a generic method. Method that can work on all of these. Okay? So rather than make multiple methods called output, one that uses integers, one that uses booleans, that's overloading. We already know how to do that. We're going to make one method that can handle all the data types. And that's what's called a generic method. Okay? So if you were to use the light bulb right here, if you were and say create method, it's going to pop it down here. Notice it wrote it as outputting a boolean. But now that's not going to work for this one because that's an integer. So I could create another method that outputs an integer. But that's overloading. We already know how to do that. And I'd have to overload all of these for all the different methods. So the idea is I don't want to do that. I want to create one method that doesn't output a boolean, but outputs whatever I want it to output right here. And that's what we're about to create. We're about to create a generic method. Okay, so how do we do this? Well, what I'm going to put here is the item I'm going to output. But what I don't know at this point is what the data type is. Okay? I can't put a question mark. A question mark is not something Java's going to understand. So instead, what I'm going to put here is just a single letter. I'm going to make it a capital letter, but it doesn't have to be. It could literally be any letter I want. Capital or otherwise. But I'm going to use the capital letter T. There's a reason for that. So then what's going to happen is, as it calls this method, okay, it's going to use whatever this is as an argument right here, and then transform that into a Boolean. And then the next time it's called, it's going to transform this into an integer. And then eventually when it gets to this one, it's going to transform this into an athlete object. So in order to make this work, okay, we're going to make a modification once again to the method itself. We're going to add some modifier words. So one thing about generic methods is they need to be static, okay? So it needs to be a static method. But then we're going to add another modifier in here. In between static and void, we're going to add a modifier that looks like this. And I'm going to put a comment in here to kind of explain this to you. Okay. Oops. Copy and paste problem. That's okay. Okay, so here's what the comment is saying. The method is going to output an item. That item is a generic item. We don't know what it is. It could be anything. Generic methods, as it says here, which is what this is, use a generic reference. So it's a generic reference there, rather than a specific reference. A specific reference would be me putting in something like, you know, word integer. That would be specific. You do not define that data type when the method is created in the parameter. So I did not define it. Instead, you use a set of angle brackets, the less than, greater than signs, with a single letter, usually capital T, but it doesn't have to be, inside, which acts as a placeholder, which will later be defined. Now, why does it use the letter capital T? Is kind of a throwback to the fact that we didn't have generics in the first version of Java. We didn't have generics in Java's parent language, C++. But But we did have something called templates, which was similar to generics, not quite as powerful. And so the first programmers who started using generics used the letter T to help remind other programmers that it's like a template. Okay, but it doesn't have to be T. All right, speaker check. Any questions at this point? All right, so let's go in and write the code for this generic method. It's pretty short, it's only 4 lines. String text equals the word class with a space. Couple lines. At the end of this, output the text. So that's what this method's going to do. It's going to output this item as text. But we don't know what the item is. It could be an integer, it could be a Boolean, it could be anything. Now I'm going to take that text and I'm going to add information onto it. So remember, plus equals means text equals text plus. So what am I going to do? I'm going to go to my item, dot, because that item is at least a class, it has built into it these methods. One of them is toString. That's good. Before I use toString, I'm going to actually use the one called getClass. GetClass returns what class this is. So in that case, it might be an integer. But built into that, believe it or not, if I put a second dot after getClass, so dot getClass, then another dot, there's built into every class in Java some nice little methods, and we're going to use this one right here. We're going to get the simple name of that class. Okay. But we're going to add one more line as well. Text plus equals some words as a string is, and then to that we're going to say item dot toString. So we're attaching a few things when we output each of these items. Now I'm going to run this. It's going to call that generic method. And here's what it's outputting. It says, well, Boolean as a string is the word true. Class integer as a string is a 0, etc. The character is an A. The string is text, and the athlete, it calls the toString method that's built into the athlete class. So watch, when it goes to this method with jock as the parameter, okay, it's going to go and get the class, which is jock, get the simple name of that class, which is athlete. And then once it's inside athlete, it's going to look for the toString method right here. So that's why it's outputting that word and then going to its superclass method, which happens to be Husky, running its toString method, which goes to its superclass, which happens to be high school, which goes to its superclass, which happens to be student, which outputs student number and its superclass toString method, which happens to be person, outputs the person and the name and the age and the is alive. And that's why all of that is coming in that output for the athlete. In our generic method, close a few of these, right there. So that's what a generic method is. Okay. Now it's time to make our last 2 classes for this project. We'll start with the first, we'll start with the first one. So I want you to make a class, right-click, new Java class. So right-clicking on the package, a new Java class, not an interface. And I just want you to call it box, capital B-O-X, box. Okay? The box class. Now, we're not going to need all the methods of the box class. So you can remove all of them. You can keep the constructor. The constructor we'll need. We don't need toString or clone for the box class. Okay, we've already looked at those. Now, here's where the box class incorporates a generic. Encapsulated into the box class will be a present, right? Like a box, right? Like a Christmas present. But we don't know what data type that present is. Maybe it's an athlete we're giving as a present. Maybe it's a doctor. Maybe it's a string. Maybe it's a J option pane. We don't know what the present object is. So we're going to make it generic. We're going to put the letter T as a capital. But this will generate an error. It doesn't know what this symbol T is. Okay? Suggestions would be creating a class called T. Well, we don't want to do that. That's not what it is. What T is it's a generic object. To incorporate this into an entire class, so the whole class can use this generic present, I'm going to add that modifier up at the class signature line up here. So now it knows what T is. Okay, I've got a comment for this. Okay. So the box class represents a box that can hold anything. This class uses a generic object as a property of the class. Whenever we use a generic data type in the class, the angle brackets are used with a letter, T. That letter can be used throughout the class, implying that data type, and it's substituted in later when the class is instantiated, okay? And this generic T with the angle brackets is put in the signature line of the class. So that's where our present is created. All right, so that T thing is the generic property of this class, which uses a data type that will be defined when the class is instantiated. Now, let's make a constructor. T present, which means our line of code would be this dot present equals present. We've kind of seen this line of code before. Which means I will add it in as a comment for my constructor that present is the generic thing to be put in the box. Why am I adding that to my constructor? Because I made it private. I made it encapsulated. Okay. Let's quickly make a method. It's a box, right? So let's make a public method to open the box. Let's have it return the data type. So it returns our present. That's what opening a present does, or opening a box. You get what's inside, you get the present. So here I'm using the generic letter T as the thing it returns. And then the final method of this class, public, a void method, but we'll just make a little peek method. We're not going to open the box, we're just going to peek inside of it. And for that, we're just going to do an output. We're going to take our present dot turned into a string. The toString method we know is built into present because although present is generic, it is a class. So this method does a little peek on the box, outputs the contents. All right, pulling back, this is our, and actually I'll collapse all this. This is our box class. Using a generic, it has one property, 3 methods. The methods are all short, 1 line. Just 1 line of code for each method, okay? That's the box class. Like I said, it wasn't going to be much code today. Most of this is comments. Let's wrap up today by putting this to use inside of our testing class right after we did all these outputs, after we called our generic method. Now I'm going to pop in a giant comment right now. Kind of goes over what we've been talking about. when we use a class that has a generic inside of it, and that class is being instantiated, then you define what the data type is. So I'm going to make a box item. I'm going to call it box1 equals a new box, and call my constructor something in the box that I'm going to be building. Yes, I will have to import box, but this is not done yet. I don't just put a question mark here. So for example, I might put a Boolean in the box. But this isn't technically how you define a generic class. It needs to know what the data type is. Because when I go to make the second box, box 2, I'm going to put an integer in that box. So one of them contains a Boolean, one of them contains an integer. So technically it requires a little more information. What it requires is right here, the angle brackets and the data type. So this is data type Boolean. Here, angle brackets, data type integer. That's a better way to define this class object with the generic data type. Now, traditionally, this is done twice. It's done once right here and once right here on the other side of the equal sign, just before the bracket for the constructor. So you do it here, here, and here. Okay, whoops, I got rid of the bracket. But Java, and that's what's written here on the comments here, included an option that you, on the second time you do it over here, you don't have to write the data type twice. And they came up with a name for this weird symbol here, and they call this the diamond. I know, isn't that kind of poetic sounding? So anywho, I realize our time is running short here. I want to make 6 boxes. Box 3, 4, 5, and 6. I want them to hold different data types. Double. This one's going to hold a character. This one's going to hold a string. This one's going to hold, okay, an athlete, right? This one holds a string. This one holds a character. This one holds a double. So this is how you define these generic class objects. Okay? It's a little trickier than creating regular objects using classes. It's definitely more advanced, okay? But now it's using this box class, which holds anything. So it's powerful if you think about it. I can make a class that can hold onto anything. Before the bell rings, I'm going to peek in the boxes. So box 1, peek. And 2, 3, 4, 5, 6. Okay. I'm going to then open the boxes, which, as you know, returns information. So it's going to return a Boolean. I'll call new Boolean. It comes from me taking box 1 and opening it. It actually opens it up. And I can do the same for a new integer. So return an integer by opening up box 2. I can get a new double by opening up box 3. That will give me a double. Whoops. Okay. If I open up box 4, okay, I get a new character. So that means I will get a character. Space this out so it's a little easy to read. When I open up box 5, I'm going to get a string. So obviously I'm going to call that one new string. And then finally, when I open up box 6, I'm going to get a new athlete. But an athlete is a person. So I'm going to use a little polymorphism here. And box 6 is going to open up, and it is an athlete, but an athlete is a person. So now I'm going to output these newly returned data types. And I realize the bell is about to ring, so I'm doing a little cheat here. I'm going to output my new Boolean, my new integer, my new double, my new character, my new string, and my new person are all going to get outputted using my generic method. Okay, so I'm going to run that. Let's see what happens. Why, look at that. The first time it outputs them, true, 0, that's me peeking in the boxes. But then, up to here is me peeking in the boxes. And then here I'm running my generic method. And notice it is outputting the same stuff as the other generic method call did. So this is a quick look at the idea of generics. We are 99.999% done. In tomorrow's class, I want to spend about 5 to 10 minutes. That's it. Just wrapping up this idea of generics and finally finishing up this ginormous example. Okay, but that's going to be it for today. I'm going to stop the recording now, and we're going to be done for the day. And you guys should have a nice day. Tomorrow is Friday.